My name's Whitney.
I'm David.
And we are going to answer a question today. Before we get into it, please like, subscribe, ding that bell so you get notifications for our new videos. So the question we got today is from Josh Jones with Substrate Technology Incorporated. Thank you so much for your question. Do you have any data or testing that shows vapor pressure being reduced or mitigated using colloidal silica on cured concrete? I think you gave me a good idea on how silicates work to slow moisture vapor movement, but do you know of any test that quantifies the result of using a silicate this way?
Well, Whitney, the answer is yes and yes.
Oh, wonderful. Well, that was easy.
Well, that was a
quickest video ever.
That was a good session. We have a lot of data that we've generated for various clients,
right,
that do flooring type things.
Right.
And so we measure the moisture vapor evaporation rate, the MVER.
Right.
And so the tests for that are ASTM F1869 and ASTM F2170. And both of them, you know these well, because I think you do most of the measurements.
Yes, yes.
We make the sample, and we have a calcium capsule that we put on top that you
right.
go through a process to
yeah, you measure it initially, and then you see how much more it weighs from taking in moisture from the slab after, I think it's right about 72 hours.
Right. So that's the way it's done. No, we use the kits.
Need a tomato.
Yeah. So we make a reference sample. We make a sample with colloidal silica.
Right.
We look at the differences between the two. And
I thought you had to be.
And then we look at the difference between the two, and we know that with the colloidal silica, it reduces the moisture, the MVER, the moisture vapor evaporation
Right.
rate. So
why do you think that is? Creating a denser slab?
Yeah.
Reducing pore size? Like what?
Absolutely. We know from many of the tests we do, we know from scantron microscope and all kinds of things that the colloidal silica helps close voids, makes it denser, so it can't transmit or emit moisture as well. The permeability is lower. And the other thing that we know that we can do, we can either use it in the mix or we can use a topical.
Okay, sure.
So there's topical admixtures we can use when we place, and there's also hydrogels we can use after we place or even later in life to cut down on moisture.
Okay, excellent.
So there's some people that don't like MVER.
Sure.
It's not a closely scientifically calibrated test.
Sure.
So there's been some criticism of it, but you know, it's an ASTM test. It is what it is.
Right.
And I think A to B, I think there's a lot of things we can do A to B.
Right.
Comparing exactly the same situation with a one parameter variation.
Right.
So we know that the colloidal silica does make a difference.
Sure.
And that improves the situation. So even if the test was horrible, an A to B comparison shows a benefit.
Well, it still gives you some data. I think that's, you know, a lot of people want like a test that's going to kind of tell a lot of information, but that's why there's so many tests out there. Like you need to evaluate it in a number of different ways using different methods to kind of collect all the data that you're looking for. So yeah. I think if you keep in mind, you know, that you have that kind of end goal, that mindset, I feel like it can provide some valuable information. And you just, you know,
absolutely
use that for what it's worth.
That's absolutely right. And as always in the lab, we try to miniaturize or simulate the environmental condition in the field.
Right.
So we can't come in the lab and run things at a wonderful Honolulu temperature, 72 degrees, you know,
and expect
blah,
it to
blah, blah.
completely translate.
And then, you know, go to Scottsdale and it's 115.
Right.
I mean, you know, we need to, this particular test, you can, it says that you can use a 72 degree 50% relative, but it's not a mandatory, so we can simulate different
different environments.
Different environments in the lab to try to miniaturize the field situation.
Excellent.
So I think that's it. I think that's what we have to say on moisture vapor. So it is measurable. It's good to have an A to B comparison with reference to colloidal silica. Our data, which is proprietary, shows that colloidal silica does make a very good beneficial change. So I guess that's it.
Thank you so much for joining. Have a good one. Go concrete.
Eat asphalt.